Hello everybody, this is Eddie DiMiro for TechHunters.com, and today we're going to be talking about bubble sorting algorithms.
TechHunters.com.
So right off the bat, I just would like to say that bubble sorting algorithm is not the most efficient out there. There are more efficient algorithms, but the reason we're studying it, it's because it's a relatively simple algorithm to understand. It's easy to implement, and it's a classic algorithm. So if you're studying data structures and algorithms, it's a good start. So without any further ado, let's dive into it. So before we continue and jump to implementation, I just like to go over some concepts here and see the theory of how bubble sort works. You should be familiar with arrays and basics of programming. This concept, this idea can be applied to any language you want. We're going to be implementing this in Java, but the idea can be applied to JavaScript or C++ or C#, or even a procedural language such as C. The important thing here is to understand the concept and what bubble sorts does. So let's say we have an array here with 5 elements. As I said before, we need to keep track of two things here that are important. Our index here, which at this point is 0, and our length of the array, which at this point is equals 4, because the length of the array is always the total length minus 1, and in this particular case we have 5 elements in there, and 5 minus 1 is equals 4. So we start at position 0, and then we ask the question, is element of index 0 larger than the element of index 1? So in our particular case here, the element with the index 0 is 20, and the element of index 1 is 15. So yeah, 20 is larger than 15, so we need to move 20 to position of index 1 and move 15 to index of position 0. So it's going to look something like this. Now, all we have to do basically is then we have to verify if I is still smaller than the length. And at this point, I is equals 0 and the length is equals 4. So I is still smaller than the length, and we can keep on going to the next element of the array. So since we're done with that, then next time we're gonna ask, okay, is the element of I, which is increased to 1, now I equals 1, is the element of I equals 1 larger than the element, actually I should put a question mark here, yeah, is element of index 1 larger than the element of index 2, which is 32? No, it's not. Then we don't have to do anything. Basically, all we have to do is just increase I here, and then verify if I is still smaller than length, and 2 is smaller than 4, so we keep going. So then we ask, okay, is element of index 2, which is 32, greater than element of index 3, which is equals minus 8? And then we're gonna see yes, 32 here in position of index 2 is greater than minus 8 in position 3. Then we do a swap, we need to call a swap function, and then 32 takes the position of index 3, and minus 8 takes the position of index 2, which is something like this here. Once again, we increase I to 3, and compare I to the length. So is I still smaller than the length? And the answer is yes. So we keep on going. Then this time we ask, okay, is the element on position of the array with index 3, which is basically 32 here, greater than the element of the array with the index of 4, which is 12. And you're gonna see that yes, the answer is yes. Then we call the swap function, and 32 takes the position of index 4, and 12 takes the position of index 3, and it's gonna be something like this. Then we increase I again, and this time I equals to 4. Now we verify I to the value of the length here, and we're gonna see that I is no longer less than the length, and then we have to stop the program. That's at the point where the program knows that the swapping has been done. The largest element in the array is in its proper position, and we can start all over again. So 32 at this point is in the proper position, which is the very last element of the array. And now we go back to the beginning of the array and repeat the process. So basically we go back to the first element and reset I to 0, but this time instead of 4 here, we actually set the value of the length to 3. Remember, at the end of the array we have always to decrease the counter by 1, so we don't go overboard the arrays, we don't go outside the boundaries of the arrays. Then we do the comparison again. Is the element on the array with index 0 greater than the element in the array with the index of 1? And we're gonna see that 15 is not larger than 20. Then we don't have to do anything. All we have to do here is increase the value of I here, and then let's put I plus plus here, and then we compare I to the length, and we see that I is still smaller than the length. So is I smaller than the length here? And the answer is yes. So we can go to the next comparison. We don't have to do the swapping here. Then we compare, okay, is the element in the index with the index 1 larger than the element with the index 2 here? And we're gonna see that yes, 20 is greater than minus 8. So at this point the program calls the swap function. 20 takes the position of minus 8, and minus 8 takes the position of 20. It's gonna be something like this. Once again, we increase the value of I to 2, compare the value of I to the length. It's still smaller than the length, and then we can do the comparison. 20 is still larger than 12, and then 20 has to take 12's place, and 12 has to take 20's place. And at this point we reach the end of the array, because when we increase I here to 3, we're gonna see that 3 is equals to the total length of the array, and it's not smaller than the length. So the program knows it has to stop and start from the beginning again. We go back to the first element of the array, we reset I to 0, and in the length we do length minus 1. Length comes down to 2. Now 15 is larger than 8, so position of index 0, the element in position of index 0 takes the place of the element in position with the index 1. 15 goes to minus 8, and minus 8 goes to 15's position here, which is going to be something like this. We increase value of I here, which goes to 1. We compare 1 to 2 here. 1 is still smaller than 2. And then we do this the comparison again. So 15 is still larger than 12. Then 15 has to take 12's position here. 12 takes 15 position here. And we are going to have something like this here. At this point we increase I here to 2, and we're gonna see that I is equals to the length, and the program knows it has to stop. So we go back to the beginning. So we once again reset I to 0, decrease the value of the length from 2 to 1, and we do the comparison again. And at this time we can see that the element in index 0 minus 8 is smaller than 12, and we don't do anything. So we just increase the value of I to 1. We see that 1 this time is equals to the total length, and the program knows it has to stop. And at this point the array is totally sorted. And that's how bubble sorting works. It's not difficult to understand, and now we're gonna see how this is done by implementing this in Java. So here we are. I'm gonna do this in the IntelliJ IDEA. We're gonna create a new project. Come here. Then I'm using Java 1.9 here. You don't need to check out any of this here. We're gonna do this in Java, and we're gonna just click on next. We're gonna ask the IDE to create a main function for us, and then also to allow us to work in the console. And then we're gonna call this bubble sorts, and then we're gonna click on finish. Then yeah, I had another project there, just override it, and there we go. We have our main function already. So I'm gonna get rid of this here, and we're gonna start on coding. Let me just give a little more space here. And well, to begin with, we're gonna need to do that swap function that I was talking about. And so we are going to put the function here. It's going to have to be a public function. It's going to have to be a static because we're going to be calling this from the main. We don't need to return anything. Let's call this swap function. And it's going to take 3 arguments, as I said, an integer of arrays. We're going to call this array, the position of I, and the position of I plus 1. Then inside this swap function here, we're going to have to declare a temporary variable that's going to store the value of the array in position I, the initial value of the array. Then if this function is being called, it's because the value of I is greater than the value of j. So the value of I then is going to take the lesser value, which is the value of j here. And that's okay with that because let me see here, let's make this a little prettier. And that's okay because we store the initial value into the temp variable, then the position with the j, the index j, is gonna take the temp here. And it's that simple. We don't need to do anything else here. And now we have to do everything in the main function here. First we need to declare the array. Let's call this int array, and we have our values, the same values that we discussed in the previous video. We're gonna have 20, 15, 32, -8, and 12. So it's an array with 5 elements in there. Then we're gonna need a function for the traversal of the array. So this is gonna keep track of how long is the array we are actually traversing, and at the end of the array, as we saw in the previous video, we need to decrement the value by 1, so we don't go overboard the array, we don't go over the boundaries of the array. If this ever happens, then we are gonna actually throw an exception in here. So let's call this last unsorted index. Let's call that, and this is going to be the size of the int array, the length, -1. So every time we get there, we decrease the value to -1. Actually, this is the initial value, and every time that we traverse the array, it's going to be decreased by 1. So we need to check to see if the last unsorted index is greater than 0, because if it's equal to 0, then there's nothing to sort. Basically, there's no anywhere to go. There's no array, to be honest. And then every time we get to the end, we decrease the array value by 1. And actually, let's close this over here. And then this is to track the length of the array. So we're gonna need an internal loop here as well, and this loop is gonna keep track of the index. So we're gonna need another for loop here, and we're gonna call this I and initiate I to 0. Then we're gonna check to see if I is smaller than the less unsorted index. As we saw before, every time that we do the swap or we do the checking, basically, we need to compare I to the less unsorted index to see if it's still smaller. And if it is smaller, then we can go to the next comparison. If it's equal, then the program has to stop. The program needs to know it has to stop. So in here, we increase I, and then we need to put our condition here. So basically, if int array in position I with the index I is greater than int array here of position of index I plus 1. If this is true, then we call the swap function. And in the swap function, we will pass the int array and I plus 1, which is going to be called j over here in the function. And then after we've done all of that, we basically just need to output the result to the screen. So we're going to go int I equals 0. Then I has to be smaller than int array length, and we increase I once we print that out. Then we're gonna go system out print line. Actually, I want to print line because I want this in a column actually. So we're gonna pass basically int array and the value of I here. So we're gonna print these values individually, and that's it. It seems to be very easy. It's not very complex, very simple implementation. We didn't have to go outside main. We did everything inside main, and just let's see if it works. So if we click here run, we first actually have to build. No. And it seems to work. So the array sorted -8, 12, 15, 20, and 32. Just for the sake of trying things, let's say that 15 here was 150. So if that was the case, 150 would be would have to be showing up at the end of the array. So if we run the array again, and this will take a few seconds, and there we go, it's sorted. So we can see 150 goes to the end of the array and everything else follows. So -8, 12, 20, 32, and 150. And that's Bubble Sorts. Thank you for watching, and I'll see you in the next video.